On Mars, we're going to be measuring temperature because having the right temperature in our biomes is going to be necessary for growing our healthy crops and keeping us alive more in Mars.
It's going.
Wait, what?
It's going.
In our project, we will be measuring temperature of the biome on Mars and our enclosures for crops and human life, as temperature is crucial for plant growth and water management.
Alas, we have a Mateo in the wild.
So we're using the DHT11 sensor, which is like a low-cost digital sensor that measures the temperature and humidity. It operates using 3 pins: the VCC power input, GND ground, and data for the signal output. It's capable of measuring temperatures between 0 and 50 Celsius with the accuracy of +2 Celsius, making it suitable for basic environment monitoring applications like controlling the climate and noise. The plan for the measurement is we're going to power the sensor, connect the VCC pin of the DHT11 to the 5 volt output on the Arduino UNO, and connect the DND pin to the ground on the board to provide the sensor with power. We're going to capture the data that the DHT11 sends the temperature and humidity readings to the Arduino UNO. This pin will be connected to digital pin 7 on the Arduino reading output signal. The UNO will be programmed using the DHT library to read the data from the sensor. It will process the data to calculate the temperature for both Celsius and Fahrenheit. Then we will output the results. The readings will be displayed on the serial monitor of the IDE, where the temperature will be updated continuously, allowing us to monitor any changes in the environment.
At the start of the code, you have to import the DHT library, which essentially includes all of the code for this guy. And within that library, there are different types of DHT sensors, like the DHT22, and this one specifically is the 11, which is why you specify that in the next line. Down here, you're just initializing that it's going to start collecting its data, and it's just kind of like a setup for the sensor. There's a delay because this sensor can be up to 2 seconds behind, and if it's just constantly spewing out data, it's not going to be very accurate. It'll also get really hard to read in the monitor. Down here, I'm defining all of the variables it's going to collect. The humidity float we're not using yet, that's a setup for next week's sensor, but the temperature is for this week. This is a print statement in case it fails. It just helps clean things up in case there's an error. And then down here, it's going to print all of these values in the serial monitor. And so it's going to print temperature, the value of the temperature, and it's going to convert it into Celsius and Fahrenheit. Print a new line, and then collect the next round again. Alas, greetings, 8 a.m. mortally sleep deprived. Anyway, we got our temperature sensor working. So here's the DHT11 and the Arduino UNO, not really Arduino, but same purpose. So this is the digital pin. It feeds into 7, though it doesn't actually matter which one. You just have to specify in the code where the UNO is going to be receiving the signal from. And that connects to the output pin for the sensor. And then the other two, very standard for any circuit, you've got the ground and the 5 volts, which feed to the corresponding ground and VCC pins on the sensor. Then the code was explained already, but here is another example of the serial monitor. So there's where it's initializing and its first temperature. And if I breathe on the temperature sensor, you'll notice it starts to increase with a 2-second delay because this sensor is very slow. Okay, so fun things were happening with this one. Essentially, I had the wires backwards, so the ground and 5 volts were going into the wrong pins, which was causing this thing to overheat to like a burning degree, and it almost broke the Uno. Fixed it, we're good. Flipped the pins. Second issue, up in the code, you have to import the DHT library, but thanks to the wonders of school Wi-Fi and everything that they block, if you go to include library, manage libraries, it blocks every single library within the Arduino IDE. So the only way to get around that is to go to, you have to essentially search for the Arduino library online, type in DHT, and then go to this sensor library to import it off of the Arduino library list. Long loop, but it got the job done. Pardon the change in scenery. Generally, our project did go very smoothly, all things considered. We did run into a minor issue with our media manager being sick for most of this week, and everyone kind of stepped up to fill that void, taking videos, pictures were needed. Me and Mateo edited the video at the end. The actual circuit itself, there were very few issues with that, and they were discussed previously, including the libraries being blocked on the school computers and having the wires backwards initially. But other than that, considering how iffy physical Arduino kits tend to be, this was a very clean project. So the resolution to the aforementioned issues were not difficult to come by. As mentioned, everyone kind of filled in the void of Michaela being out, and I hope she feels better. The wires, simply switched them. I did have to play around with it for a little bit, because, like, why is this thing 200 degrees? This isn't right. And I'm like, oh, okay, yeah, VCC's in the wrong port. But that was very simple. The Arduino library is just how to get a little bit creative, because the IDE that it pulls from, it's not local specifically to where you'd program in an Arduino. That's also available on the internet, and you just had to explore and find some weird little links to access those downloads elsewhere. So I was able to get the DHT library there, and everything else went very well. Through this project, we did learn the importance of precise sensor calibration and how critical timing is when working with data collecting components like the DHT11, especially as a fairly cheap component that has a notable delay and a 2-degree range of error. We also gained hands-on experience with the wiring and coding for the Arduino platform, which allowed us to troubleshoot issues that engineers face in real-world projects. Additionally, the project taught us that failure is part of the engineering process, and through trial, error, and teamwork, we can overcome the obstacles to get as accurate results as possible. Ultimately, we learned how to approach problems systematically, adjusting both hardware and software to meet the project's needs. This reinforced valuable lessons about patience, persistence, and collaboration in the engineering field.